Hey everyone, and welcome to a new video. It's Federico here, although you cannot see me. I'm here. And today I'm going to show you how you can create and animate multiple copies of the same 3D shape in Max MSP Jitter using an object called jit.gl.multiple. So, without any further ado, let's start programming. And the first thing we want is our JIT world. As always, I'm going to call it my world. Let's give it full scale anti-aliasing for the aliasing. Let's give it floating one so the window doesn't disappear behind the patcher. Let's give it enabled one so it's enabled by default, and I think this is it. Let's create a toggle here. In case we want to switch out the world, we can just press this toggle and the world will be switched off. Let's actually load the mess. It with a 1, so it will start on, so we know that the world is enabled when we first load the patch. Great. Let's change the background color because gray is a bit depressing. So let's right click on the input here with the patch unlocked and choose the erase color attribute. Let's click here. And then we can select a nice background color, like nice green, for example. Cool, so let's create a GGL grid shape here. And this will be a sphere by default. And it's a bit too close to us, so let's create a camera so we can go around in the scene and get us a bit farther from the sphere. And let's create a GGL camera. Let's give it the look at attribute, so it will always look in the center of the world. And let's say lock look, so we know that however we move this camera, it will always look at the center of the world, the position 0, 0, 0. And let's create a jit.anim.drive. As we saw in the previous video, we can give it UI listen one, so it will listen to our keyboard input. Let's give it a speed of 20, and that's it. Let's connect it to the camera so we can now move around in our scene. Let's give to the camera the attribute tripod one also, so it will never tilt, will always stay parallel to the ground. Okay, great. Let's create a GGL material so we can, our shape will look a bit better. Let's give it a color like red, for example. Cool. Now, what it is, if you want to have 100 of those grid shapes, we will have to create like multiple of those and assign a different position attribute to each of them, right? And this will take so much time and will be super cumbersome. We don't want to do it like that. We want to use this object, which is called jit.gl.multiple. So let's create it. Now, jit.gl.multiple takes an argument, which is the drawing context, and we set it to my world, and then takes another argument, which is the number of input. Now, each input will be associated with a GL param. So we created this attribute called GL param, and we can choose between several transformation attributes. For example, we can choose the position, so we can create multiple copies of the GL grid shape that will have different positions. In order to know which GL parameters available we got, let's right-click on the object, go into Open jit.gl.multiple reference, and let's go down to GL params, and we will see a list of the valid parameters. Valid attributes are position, rotate x, y, z, scale, color, texture, text plane S and text plane T. Actually, text plane S and text plane T I think are deprecated, they will not work anymore, but all the others will work. So, great for us. Let's go back to our patcher, and we know that position is one of them. So let's connect these to the GGL grid shape. And as you can see, nothing happens. So in order to set the different positions for the GGL.multiple, we need to pass a matrix to its inputs. We need to use matrices to set those parameters. So let's, for example, create a jit noise with 3 planes, because each plane is going to correspond to a different argument for these parameters. So we know that position has 3 components, X, Y, and Z, because if we open here the position attribute of our GGL grid shape, you can see that it has 3 components. One is for the X-axis, one is for the Y-axis, and the other is for the Z-axis, right? So we know that these are 3 components, so we need to use a matrix with 3 planes. The first plane will be the position X, the second plane will be the Y, and the third plane will be the Z, right? Planes are indexed from 0. This is why I set at 0 here and 1 and at 2. Great. Then we need to set the type. We don't want char because the char type will give us values that are in between 0 and 255, which are super big numbers for our JIT world, right? If we set like, I don't know, a number greater than 1, our sphere will just disappear because the JIT world has these measurements in units, and a 1 unit in the JIT world is already a pretty big distance. So as you can see, when I set the distance here to 2 and 3, it's already going out of the screen. So imagine if you will set 120, this would be way too much. So we want to have the float32 type, which will give us number between 0 and 1 for the noise, right? This is very convenient because we can then multiply this matrix for a number at our choice, so it's very easy to scale. Now the dimension argument of this matrix will mean how many of the shapes we will have. So if we set it to 10, this means that we will have 10 different spheres. Now let's give it a try and let's bang this JIT noise and let's see what's happening. Cool. So as you can see, we got a bunch of spheres, all kind of cramped into each other, because the values from JIT noise, as we said, only go between 0 and 1. This object has already 1 unit of radius, so when we set them in the position from 0 to 1, they will all go into each other. So in order to make this a bit more interesting, we can use jit.multiply, set a value of like 10, so this will give us value between 0 and, you guessed it, 10, right? Floating point, so with all the decimal numbers in between those. And now if I zoom a bit out with the camera using my keyboard, you can see that we got 10 shapes and they're all spaced up between 0 and 10. So the x, y, and z components of these of the position of these objects are all in the range 0 to 10. And we can have as many as we want, or as many as our computers allow us to have. For example, in this way, I have 100 of those. And as you can see, they are all in the positive axis position, right? Because the numbers only go between 0 and 10. So if we would like to have them spaced uniformly around the center, we could use something like jit map and say map 0 to 1 between -1 and 1. This will map the input between -1 and 1, right? While here the default output was between 0 and 1, and now we will have here that the output goes between -10 and 10, right? First we map the 0 to 1 to -1 and 1, so they are centered around the center, and then we multiply by 10 to have them distributed around the world. Very cool. Now let's try to add another parameter, for example the scale. So let's go here and add a new input, and let's add a new GL param, which is scale. Let's create another JIT noise here, and let's give it only one single plane because we want to use the same value for the x, y, and z components of the scale. If we go here, we see that the scale attribute has 3 components, one for the x scale, one for the y scale, and one for the z scale. But if we use a single number for that, it will scale all the 3 axes uniformly, and that's what I want in this case. So let's connect this here and see what happens. Let's bang both these matrices, and as you can see, nothing is happening. And I just discovered that I made a very gross mistake, which is I wrote GL param, it's actually wrote GL params, but for some reason it was working all right. But actually it's GL params with an S. I got an error here in the console that told me about that. So as you can see, even after decades of max usage, I can still make these sort of errors. I guess this makes me human or something like that. So this doesn't work still though, because we are only setting the scale for one single axis and setting 0 and 0 for the other 2 axes. So what we want to do is to create a JIT matrix, give it 3 planes, give it the type float32 and set it to 100. So what this will do is that we'll just use the same value for the 3 planes. So we can check that using like JIT window. In this case, this will look like this, and in this case, this will look exactly the same, but this time we have 3 planes that all contain the same value. We can set this maybe better with jit cell block actually. So let's go plane -1, which will show us all the planes. You can see that they all have the same value, while here this was only a single plane with this value, and now we copy this value on all the 3 planes basically. And so we got 3 planes, and so this is now working. We got all the spheres scaled different scale. Let's reduce here the radius of our spheres distribution. Set it like -5 to 5. Nice. Let's create also a trigger bang bang to trigger first this and then this matrix output. So we can just press a single bang and this will update both these matrices. Cool. Let's try to change the shape here into a cube. Nice. And let's try to give those cubes a different rotation angle. So we know that rotation is one of the parameters that we can change from jit.multiple. So let's write here rotate x, y, z. And let's add a new input. So again, let's create a new noise, this time with 3 planes. And let's create a bang here. And let's connect this to the 3rd input. So this will be the rotation, right? This is the scale, and this is the position. So let's bang here, and as you can see, they're not really rotating because this expects the values to be in the range 0 to 360 because this is a rotation in degree. So the values that come out of here are between 0 and 1. So what we can do is again go with jit.multiply, volume 360. I don't need to put the dot here because this is already a float 32 matrix, so will always give us an output a float 32 matrix. I don't need to specify that this should be floating number, but I can do that. So this will now go between 0 and 360. And let's give it a go. And cool, this looks pretty cool. Now we got all these cubes rotated. Some are very small, some are very big. We can maybe try to reduce the scale range with another multiplier here. And we just multiply this, for example, by 0,5 or something. So they will be not so big anymore, maybe 0,8. And if we want to have like a minimum scale, we could add an offset to that. So after we multiply, we could add a jit plus and add a little offset of 0.2, which means these cubes have always a minimum scale of 0.2. Maybe we want to have a minimum scale of 0.1, something like that. So in this case, the range is going to be 0 to 0.6, and in this case, it's going to be 0.1 to 0.7 after our little offset, right? Okay, let's now see how we can animate all that. So in order to animate that, we want to basically have a matrix that is constantly changing. And in order to animate this matrix, we can use the jit.mo package. So if we go into packages, and you search for jit.mo, I think it's installed by default, so it should be available for you if you are on Max 8.6.3 or another recent version. You should have jit.mo. In any case, I really encourage you to download always the latest Max version, which you can find here at cycling74.com/downloads, and I really encourage you to often download the latest version available, in this case 8.6.3. If we want to use Perlin noise, we can create an object called jit.mo Perlin, which will give us Perlin noise, and then we need jit.mo join to create a 3-plane matrix out of that with 100 cells into it. And in fact, we probably want to copy that 3 times. So each one of those inputs will represent a different plane for rotation. We can then connect these, instead of these noise matrix, we can just connect these here. Now what we need to do is to change the speed attribute of those jit.mo Perlin. So we can use a speed message here and start to make this matrix come out. But as you can see, still not doing anything. And that's because we need to scale these values between 0 and 360, as we saw before. As you can see now, they're probably changing actually very fast. So let's maybe reduce the speed. But they're in the range 0 to 1. So we want to scale them to the range 0 to 360. And I think we could just apply a multiplier here and multiply again by 360. But there is a built-in way to do that, which is we can use the scale attribute of the jit.mo purlin and just set this to 360. Cool, and now as you can see, the rotation is being animated. Let's actually hard code the scale here in the 3 objects. Yeah, we can load mask the speed to something like 0.05. Now, the thing is that when we will create these objects from scratch, when we open the patch next time, the Purlin noise will all have the same values, right? So they will create the same values. As you can see, we are seeing a single white color. So in order to change that, we should change the phases of those Purlin noise generators. So they all start at a slightly phased out point in time. So now this will give us a more interesting rotation. Cool. We could of course do the same for the position. And actually maybe let's do that. I didn't want this to become a tutorial on jit.mo, but jit.mo is really cool. So let's actually use it. So let's make a bit of space and let's change the position. Instead of using our fixed here noise matrix, which I'm actually going to delete since you anyway I've got this on video. And let's go here. Let's create another jit.mo join. This time I don't want to use jit.purlin. I'm going to use jit.mo.sign, which will basically generate a sign function. So it will go to check this with jit.p window. We can see that it generated a sign for each cell of this 100 cells matrix. So you can see that this goes into the negative, then here we're going to the positive. Even if we want to animate that again, we can just use the speed attribute and just changing to something like 0.0.5 again, or maybe a bit faster. And cool, this is going to change the X position of our cubes. Let's now change also the Y position. Let's also reconnect them to the same speed. And in this way is giving us like the cubes are going to move on a diagonal. So if we want to move them on a circle, we can change the phase of this sign by 0.5. So in this case, when we create them both from scratch, this will look like a circle. We just need to make this circle a bit bigger, so we can use the scale value here and change the radius basically of this circle with the scale attribute. And let's also load mass here 0.5 or something. Cool. And now we got our cubes rotating and at the same time have this rotating circle. That's kind of cool. We can change the speed of that. And we could, of course, tie this to some audio input. We could have like the rotation becoming faster or slower according to the audio input. Okay, let's just do that since we're already here. So let's just get drum loop, for example, right? And then I'm just going to use a simple snapshot for that, just getting its amplitude. Let's send the world bang here from our world, which is the bang that comes out at each frame as we saw in the previous videos. And let's connect it here. So the snapshot will give us some output. Let's connect this to our output so we can also hear that. Let's loop that. Okay, so this is a very simple way to get the amplitude of this sound. And then we can just connect this straight away to the rotation speed. Maybe get just the absolute value of that, so we'll just give us positive numbers and then maybe multiply that by 10. It's not really a tutorial about audio reactive interaction, but maybe just by 2 or something. But yeah, just to give you an idea of what you could do with jit.multiple and jit.mo and audio interaction. If we want to have this a bit smoother, we could use a jit slide here and say it slide up 5, for example, and slide down 10, which will give us, so this jit slide will use several frames, so several matrices, will interpolate between them, so will give us a much smoother output than if we will just connect this to jit.mo join. As you can see, this like smoothly changing. Okay, you don't really see it from the jit.p window, but you can see it in the result in our rotation here. So cool. We could do the same, of course, for the circle speed. And again, I guess let's just do that. Let's use a jit slide also here. And let's multiply though that by a bigger value, so like 5. After we multiply by 2, and let's see what we get. Right, let's maybe multiply it by 10 or something. Okay, and we get our audio-reactive cubes circle. Oh, I just changed shape, actually by mistake, but yeah, we can also experiment with that. Tortoises, for example. Oh, and we could also change the color of each one of those shapes. So let's just do this quickly. Let's add a new input. Let's actually click here. And the color now, as you can see, the shapes became all black. So we could simply just assign a different color to each one of those shapes. And we can do that using a jit noise, this time with 4 components, because 4 planes, because the color is an attribute that has 4 components for red, green, blue, and alpha, right? So we can just connect this here, give it 100 as a dimension, since we have 100 shapes, and just bang that. And then each shape will have a different color. We can also load bang that, or should load bang that. And there we go. Alright, so this was it for this tutorial. I hope you found it interesting. If you have any questions, don't hesitate to contact me here, or you can join my Patreon so you will support the creation of those videos, and you can get in contact with me, get access to all my previous patches, which are hundreds and hundreds, and increase your max knowledge by multifold times. So, thanks a lot for watching, and I will see you in the next video. Have fun. Ciao.